Saving the best for last. Okay, this topic is kind of a throwback to that very first demo in that very first the video you saw with me with the horseshoe magnet and the wire. We know that permanent magnets have a magnetic field, and those field lines, they always point from north to south. That was from the note we did on field theory, the last topic. That's just what they do. They always point from north to south. We now know, hopefully you're buying into this, hopefully you're don't have any, I can maybe find some YouTube clips for you to see it better, but hopefully you're buying in that whenever we have current moving through a straight wire, that wire also has a magnetic field. And what we said way back at the beginning, it takes two of the same fields overlapping to make a force. Two gravity fields, gravity force, electric fields, electric force. In this case, we've got two magnetic fields to create the magnetic force. So what we've got from that earlier video, if we put a wire with electricity near a permanent magnet, that'll create a force on the wire. This is a huge deal. Engineers really love this because now we can use electricity and magnets to make a force or to push things around, or tying it into grade 11 physics, tying it into work and energy. We can engineer things that'll literally do our work for us. As an example, back in the day, like I'm not even this old, so before my time, if you needed to start your car, you would have to do the work. You'd literally have to go to the front of your car, grab a crank, and crank start your car. Not unlike how you might have to start your lawnmower at home by pulling a rope. You pull the rope to spin a thing. On cars, they didn't have a rope. You literally had to spin the handle. Old school airplanes, they'd have to grab the propeller by hand and manually spin the propeller to start the gas engine of an airplane, or crank this thing to start the gas engine of a car. That worked, but engineers, now that we've figured out this cool science, they created electric motors. So now you don't have to go stand at the front of your car and use your arm power to start it. You just turn the key, and the key triggers an electric motor. Or maybe you got a push button to start that electric motor. So an electric motor does this spinning that we used to have to do by hand. There's all sorts of examples of the good things electric motors can do. Now we can build elevators, electric toothbrushes. There's so many places where there's electric motors, hard drives in computers, the blender that may be used to make your smoothie for breakfast. All of these things are powered by electric motors. So it's kind of important, it's kind of cool if we can figure out how these electric motors work. The basic of these electric motors is something called the motor principle, and it's got its own left-hand and right-hand rule. Basically, if we've got a current cutting across a magnetic field, there's a force on the wire. There's three vectors we have to look at. There's the direction of the current, the direction of the magnetic field, and the direction of the force. So here is the left hand and right hand rule for motor principles. Just like before, we'll use our left hand for negative flow and our right hand for positive flow. The geometry this time is different. Instead of a hitchhiker hand, make a high five hand. So imagine you're about to give someone a high five, but stick that thumb out so that your thumb is kind of at 90 degrees to your fingers. I got that little graphic there. That was kind of the best one I could find. In this motor principle stuff, we've got one wire flowing through a magnetic field. So unless something weird's going on, if you look at your hand, what do you have one of? You've got one thumb. So a little memory trick, your one thumb matches the one wire. Now a little sort of, I don't know what the right word for this, matching the letters. You've got many fingers. Have your many fingers match the magnetic field lines. So high five hand, one thumb match the one wire. Many fingers match the magnetic field lines, north to south. So your fingertip should be kind of by the south pole. The base of your finger should be by the north pole. When you orient your hand that way so that your one thumb is matching the one wire, your many fingers are matching the magnetic field lines, then your palm is in the direction that the wire is going to be pushed, the direction of the force. So thumb matching the current, fingers point from north to south, then your palm tells you the direction of the force. And kind of like we did before, left hand for negative, right hand for positive. All right, let's try an example or two. Here we go. Current is flowing through a magnetic field. From your perspective, negative flow. So as soon as you read negative flow, what does that tell you? Going to use our left hand. So using your left hand, make it shaped like a high five because it's a force question. The negative flow is moving to the left. Okay, so with your left hand, have your left thumb point left. Now, with your left thumb pointing left and a high five hand, articulate your hand and your arm, your wrist, so that the magnetic field or your many fingers are pointed towards the ceiling. All right, so you got a high five hand. Using your left hand, point your left thumb to the left. Then point your fingers towards the ceiling. When you do that, I want to know the direction of the force. Really what I want to know is which way is your palm facing? You got a 50-50 shot. Is your palm facing towards you or is your palm facing away from you? You should get, you can scroll down and see it, your palm is facing towards you. How do you draw a vector that's coming out of the page and towards you? Imagine an archery arrow coming right at your face. You're going to draw that as a dot. All right, here's the typed answer. Well, that went a little bit too fast. Sorry about that. Here is the typed answer. If I were to type it, I would, if I were to give a diagram to show that the magnetic field, so that your fingers are pointing towards this, the magnetic field was up, the north would have to be down low and the south would have to be up high. But we'll build towards that. To get to point that it said that the negative flow is to the left, I'd give you a little battery to get you to get to that direction. As long as in this first one you recognize that the answer was these dots, the wire is going to be forced towards you. That's what I was hoping you get out of the first one. Let's try another one. Positive flow, what does that tell you? The fact that it's moving away from you, what do you have to do with the appropriate hand? The magnetic field is pointing from right to left. What does that tell you about your hand? And then finally, what's the direction of the force? Okay, you got to try it to get it, so hopefully you tried it. Positive flow means you're going to use your right hand. This part means the current's moving away from you, so that means your thumb. So take your right hand and orient it so your thumb is pointing away from you. The last part is now articulate your wrist so your fingers are pointing from right to left. Okay, I'm going to put down my pen so I can try my right hand, my right thumb pointing away from me. Already that's awkward. Now I need my fingers to point from right to left. So it's kind of awkward on me when I do that. Oy. But when I do that, which way is your palm, or which way is my palm facing? When I do it, I got that my palm was facing up. All right, let's see if I did it right. Let's see the answer. There we go. This one's an awkward one. Fingers had to be pointing from right to the left, so your fingers are pointing that way. Your thumb is pointing away from you, so it's tough to draw that away. A better way to draw away, get rid of that. A better way to draw away would be an X. So your thumb is the X, and when you do that, your palm is pointing towards the top of the page. So the force would be up or towards the ceiling. If I had to draw this with like schematics or sort of proper symbols to show the magnetic field, to show that my fingers are pointed from right to left, that means the South Pole is on the left and the North Pole is on the right. To show the current being away from you, I couldn't really draw the battery. So, oops, that doesn't work. So I would just draw an X to represent the current flowing away. So I'd have to have my fingers pointing from north to south, so to the left, my thumb pointing away, and then I get that it's pushed upwards. So the big red arrow in here is the answer. The force is upward. It's a little bit awkward. There's a third example. Oh, we'll do the third example together. Then I'll shut down the video. This is kind of leading into, remember that J.J. Thomson that discovered the electron? This is kind of leading into what he did. So now we've got an electron. What do you know about electrons? Therefore, what does that tell you? Which hand are you going to use? The electron is moving towards the ceiling. So with the appropriate hand, what does that tell you? Palm, finger, thumb. The magnetic field is away from you. What does that tell you? Palm, finger, thumb. What is the direction of the force? So I'm going to pause. Hopefully you think for a moment. An electron is negative. So that means we're going to use our left hand. The electron is moving up towards the ceiling. So it's not in a wire anymore, but it's still telling you the direction of the current. So you need to take your, what matches the one wire? One thumb. So your thumb is towards the ceiling. So take your left hand, take your left hand, make it a hitchhiker hand, and point your left thumb towards the ceiling. Now when you've got it like that, what matches the magnetic field? Magnetic field, many fingers. Oops, bad spelling. So fingers away from you. When you do that, your left thumb towards the ceiling, your left finger's pointing away from you. The question wants to know the direction of the force. The force is your palm. In this case, your palm is pointing to the right. So if you can read that sentence that I typed there and you know that the final answer is that the force is to the right, you're in good shape. I'm going to show you a little picture and how I would sort of type it up or write it up if I was going to give this, when I give this to you on an assignment. There's the answer, the picture of my hand, and there's kind of how I would type it if I had to type it. To show the magnetic fields pointing away from you, instead of showing the north and south pole, I would literally just give you a bunch of X's and say the X's represent the magnetic field. Because it's an electron that was fired, I would literally draw a little negative with a circle around it to represent the electron, and then an arrow to show you which direction it was moving. So what I just covered in purple there, that's what your thumb should be doing. And then the red arrow is the answer. This thing will get pushed to the right. That's where I'm going to pause the video. There's lots of cool stuff. There's another video there. There's a summary there. Read through that slowly. That's where we're going to, well, that's where I'll pause this one.